Okay, so let's have a look at chapter 1. Chapter 1 is matrix. So what is matrix? Okay, matrix is an arrangement of data in the form of column and row. Okay, so it is a rectangular array in order of m times n, where m is number of row, and n is number of column. Okay, so normally, let's say A is the name of the matrix where the data is arranged in the form of row and column. So this is the symbol of matrix, and inside is called an element. Okay, element we state as A subscript 1 1. Okay, Aij. Okay, Aij. Aij is element, is called an element of matrix A, where I refer to row where the element is located at. Okay, is number of where is the number of row. Okay, row, and J is number of column. Okay, so A11 means that A is placed at A11 means that A is placed at row 1 and column, so this is row and column 1. Okay, so again we have A12. A12 refer to element row 1 column 2. A13 element placed at row 1 column 3, and so on. A21, A22, A23, A31 element A placed at row 3 column 1. This is number of row. Row 3 column 1. Column 1, column 2, column 3. Here row 1, row 2 and row 3. A23 and A33. Okay, so matrix A is an arrangement of data in row and column. Okay, normally we can find this in a spreadsheet in Excel. Okay, spreadsheet, Excel, where we input data. Where you input the data here regarding to column 1, column 2, column 3 and so on. Here is row 1, row 2 and row 3 and so on. Okay, so this is matrix. This is what we call matrix. It's a collection of data in order placed by row and column. Okay. Okay, size of the matrix is given by, so this is the element. Okay, size of matrix, for example, A m times n, meaning that the size of the matrix in order where the number of row is m and number of column is n. Column is n. For example, A is given by 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, number of row here 1, 2, 3. So m is 3, and number of column here is also 3. So n is 3. Okay, so we write rank of a matrix, okay, as A 3 times 3. Alright. Okay, example. Okay, let's say now we want to find, given this matrix, we want to find what is, find A 1 3. Okay, small letter A referring to elements in matrix A. So capital A is the matrix and lowercase a is the element of matrix A. Okay, so A13 we refer to row number 1 here, row number 1 and column number 3, column number 3 here. So the answer is 3. Okay, next find A32. So we refer row number 3, 1, 2, 3, row number 3 and column number 2, column number 2 here. So the answer is 8. So this is how you find the element of a matrix. Okay, next is types of matrix. Okay, first, square matrix. Square matrix is where m equal n. For example, matrix A 2 times 2, matrix B of type 3 times 3, matrix C of type 4 times 4. Okay, this is a square matrix where the number of row equal to the number of column. Okay, example, A is 1, 2, 3, 4, B is 5, 6, 7, 8, 1, 2, 3, 4, 5. Okay, 2 times 2, 2 times 2 matrix and 3 times 3 matrix. Okay, so that is called a square matrix. Okay, next is diagonal matrix. Diagonal matrix. Okay, diagonal matrix is a matrix where the real numbers on the main diagonal and 0 elsewhere. Okay, it means that the main diagonal, it is a square. First, the matrix must be a square matrix. Must be a square matrix, but the diagonals represent the real number and 0 elsewhere. Okay, example, matrix 2 times 2. The diagonals represent the real numbers 1, 0, 0, 2. The diagonals is the real numbers and 0 elsewhere. Okay. Another example. Okay, this one also is considered as this one should be 0, 0. Okay, this one also is considered as diagonal matrix. Okay, real numbers in the diagonal part. The diagonal part, real numbers is 0 also including real numbers. And not the diagonal element is 0. Elsewhere is 0. So other part is 0. So this is also considered as diagonal matrix. Okay. The diagonal matrix is either 0 or not 0, but elsewhere is 0. Okay. The diagonal part is either 0 or not 0, and elsewhere is 0. So this is called diagonal matrix. Okay. Next is identity matrix. Okay, identity matrix is a square matrix with 1 on the main diagonal and 0 elsewhere. Identity matrix is a matrix. It's a diagonal, but the diagonal element is 0. The diagonal element is 1. 1, 0, 0, 1. The diagonal part must be 1. Elsewhere is 0. Okay, another example. This is a square matrix. Identity must be a square matrix first. Square and diagonal. Okay, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is also identity matrix. Alright. Okay, next is transpose matrix. Okay, transpose matrix is a matrix. Let's say A is a matrix of order m times n, number of row is m, number of column is n. Transpose matrix, the symbol is given by AT. T, A superscript T, means that A transpose. So the order of the matrix, the row become column and the column become row. So it become n times m. Okay, example. Okay, example. A given by 1, 2, 3, 4. So A transpose is row become column, column become row. Row number 1, 1 and 2 become column number 1, 1 and 2. We arrange in a column base. Okay, 3 and 4 become column number 2, 3 and 4 like this. Okay, another example. Another example. B given by 3, -1, 2, 0, 5, 4. So this is 2 times 3. So for B transpose, it should be 3 times 2. So row become column, column become row. So we have 3, -1, 2 and 0, 5, 4. Okay, this is a transpose matrix. Okay, next is symmetric matrix. Okay. Next is number 5. Okay, symmetric matrix. Symmetric matrix is a square matrix where A transpose and A is the same matrix. The element and order of the matrix is the same. So we call that symmetric matrix. Example, let's say A is given by -18, 8, 8 and 3. So A transpose is -18, 8, 8 and 3. So A and A transpose are equal. The element and order also are equal. So A equal to A transpose. So A is called symmetric matrix. Alright. Okay, next is number 6 is skew symmetric matrix. Skew. Skew symmetric matrix is a square matrix where A transpose is equal -A. Okay, for symmetric matrix, A transpose equal A, but for skew symmetric matrix, A transpose is equivalent to -A. Okay, example. Let's say A is 0, 8, -8, 0. And now we find A transpose. A transpose is 0, 8, -8, 0. Okay. Okay, now find minus A. From here, minus A means that negative, we multiply each element here by negative 1. So it becomes 0, negative 8 and 0. So this is equal A transpose. So A transpose equal negative A. So A is called Q symmetric matrix. Okay, next is row and column vector. Okay, number 7, row and column vector. Okay, for row and column vector, for row vector is a matrix with only one row. Okay, example, A given by is only one row. 1, 2, 3. 1, 2, 3. Okay, so it means that the order of the matrix is A 1 time n. M is always 1. Okay, M is always 1. And n can be of any positive number, positive integer. Okay, this is called row number, the row vector. 3, 4, 5, 6. Okay, so B is 1 time 4. Okay, okay, so opposite to column vector, row is always 1. For column vector, the column is always 1. Column vector column is always 1. Okay, example B 1, 2, 3. So B is a matrix of time M time 1. N is always 1. M can be any number. So for this case, M is 3. B 3 times 1. Okay. Okay, next is number 8. For number 8, lower and upper triangular. Okay, for lower and upper triangular, lower triangular means that A is a element in order ij where aij equals 0 for I less than j. For all number of row less than number of column, the element is 0. Okay, example, A is 1, -3, 7, -4, 0, 5, 8, 4, 0, 0, 3, -2, 0, 0, 0, 4. Okay, so Aij is 0 for I less than j. Okay, this is A 1, 2. 1, 2 meaning that I is 1, A 1, 2, I is 1, 2 is, j is 2. So 1 less than 2. So I less than j. So that's why A12 is 0. Here is A13. Okay, I is 1, j is 3. So I less than j. I less than j. So that's why this is 0. Here is I14. I is 1, j is 4. So I less than j. The value here is 0. Okay, and here is A21. 21, I is number 2, j is 1. So I is not less than j. So that's why this is not 0. This one also A22, not I less than 2. Here is A23. A23, I2, J is 3. So I less than J. So that's why it is 0 and so on. Okay. So that's why we call this as lower triangular. Okay, for upper triangular, it is opposite to lower triangular where Aij is 0 for I greater than J. Okay, example. Three five zero zero 7930 -5 -2 64. Okay, here is 1 1. 1 1 1 1 is not here, so it is not 0. Here is 1 2. 1 2 I less than J. That's why it is not 0. This is 1 3. 1 3 I is less than J, so it is not 0. Okay, for other part where this is A 2 1. 2 1, 2 is greater than 1. A 2 1, 2 is I, 1 is J. So I greater than J, that's why it is 0. Okay, A 3 1 here. A 3 1. I is 3, J is 1. So I greater than J. Okay, I greater than J, that's why it is 0. Here is A 4 2. A 4 2. I is 4, J is 2. Okay, so I greater than J. So that's why it is 0. Okay, and elsewhere also the same. We follow the same step. For I greater than J, it must be 0 and elsewhere not 0. Okay. Okay, last one is zero matrix. Zero matrix. Zero matrix means that all entries are 0. Entries means the elements. All entries are 0. So we call this zero matrix. Example, A is 0 0 0 0. This is zero matrix. Another example, 0 0 0. Not necessarily square matrix. As long as the matrix elements are all 0, we call this as zero matrix.